Hi, my name is Neil Bertrando with RT Permaculture, and I'm here to talk about low-tech erosion control as part of our upcoming online course. Today, we're going to talk about a technique called wattles, straw wattles or socks. Ideally, this can be used with coconut coir. Straw is also a good option, and I personally prefer to use a natural fiber wrap. Generally, this is a jute or a burlap wrap. Many times you'll see the common industrial ones are wrapped in plastic, which is said to be biodegradable, but is often left in the landscape. And so I try to avoid extra plastic in the landscape and stick with natural materials. These biodegradable wattles are a little bit more expensive than the plastic wrapped wattles, but they're also significantly larger, and I feel that it's worth the cost. So a straw wattle or a wattle is basically a long linear tube of material that's wrapped in plastic or burlap or some other sort of material. You can also make wattles out of bundles of sticks, things like willow or brush in the landscape, if that's what you have available, and you bundle it into a long linear bundle. And generally they're placed across the landscape along the contour or in some sort of orientation that may be slightly off contour, designed to slow and spread the flow of water. Some of the things that are important when you're placing a wattle is that you key in a little trench, and so that the wattle is actually just slightly below the surface of the soil. And this makes sure that the water doesn't just track right under the wattle. Many times wattles are just placed on the surface and staked in, and the water can just go right under the wattle in that case. So key in a little trench, and then that soil can be used to backfill and start the kind of terrace and deposition process uphill from the wattle. So it's ideal to just dig that trench and dump the dirt uphill, and then as you place the wattle and stake it in, then you can backfill and tamp it to make sure that the wattle is stable on the site, as well as the terrace is started and the water can't just go under the wattle and continue down the hill. Another thing that's important when placing a wattle is to actually do a little bit of measurement of the slope or the contour of the site. So it's not shown here, but we used a bunyip level. Actually, it is shown here. We used a bunyip level or a water level to do this measurement. And that is this tool right over here. And that uses the water to measure level. You can use a laser level, you can use an A-frame, you can use any sort of tool to measure the level. And we measured a contour across the landscape, and we created a slight fall from the ridge out here, or to the ridge out here, from the valley here in the center. So here's the center of the valley. And we measured with just a slight fall to the ridge on that side and the ridge on this side to position the wattle. And so that will divert water from the concentrating section of the valley center and out to the spreading section of the landform on the ridge. And it will slow the water, and in large flow events, the water will then just pour over the wattle as well. Another thing that's important to note when you are constructing wattles is that the point where the two, if you're putting more than one in, the point where two join is an important thing to consider. Sometimes people will put them end to end. I prefer to do a slight overlap and do a shingling. So the downhill slope is slightly directed that way. And so the downhill wattle is this one. And so it's shingled underneath the uphill wattle there. And you can see the same thing on the other side. This is the downhill wattle right here, and it is down slope from the uphill wattle, and they overlap by about 6 inches. And that just makes sure that the water doesn't go right in between the two wattles. It means that it has to continue flowing along the wattle and being slowed down. You can also put these directly on contour, and that's a totally appropriate and adequate way to do it as well. So you can see that these wattles made out of straw, probably some straw seed in them. You can see that it looks to me like wheat straw there growing up. in a couple of sections where the wattles really held the water, and that there's, water's been slowed, vegetation responses occurred, you're getting sediment deposition in these locations. And we spread these out in a few places across the landscape. And this wattle here, the lower one, is also associated with a couple of fish scale straw mulches, which we talk about in a different video. And so we were just looking at the different cost and treatment effectiveness and locations for placing treatments on the hillside to treat rill erosion. In this case, the rill erosion had been created across a large portion of the site through historic disking that was conducted to remove vegetation for fire prevention. And that disking, much of it was done up and down this slope. And that created rills, since the slope was denuded of vegetation and also cut into so that water couldn't spread out effectively. So this has started to heal that rill erosion and created specific areas of water infiltration and revegetation. Another thing you can see on this slide is we used rebar stakes and put some caps on them just to be safe. And once the wattle has served its purpose and the area is revegetated and the wattle is decomposed, you can go and collect those rebar stakes and reuse them. Personally, I prefer wooden stakes, but this is what we had available, and so it's what we used, rebar stakes with plastic caps, which is a common industrial application. But you can also get and apply wooden stakes depending on the soil type that you're working in.
What I love about this, like I've loved about the rest of the techniques in the low-tech erosion control toolbox, is that anyone could pick this up. Anybody could find a contour. Anybody could pick this up with the very simple instructions you've given today and take something that has been erosive and has been a degradation of this site due to disking on slope instead of disking, let's say, on contour, or just helping to remove some of the erosive potential of this site, and really stops it. You can see this in such a short amount of time. How long was this site implemented before this photo was taken? Like, what are we seeing in terms of progress here?
This is about 70 days, but it's, the rainy season has come on, so you can see the date on there is actually not accurate. 1/28/2011. This project was done in late 2016, early 2017. So this, and in Southern California, that's the rainy season, December, January, February. So right after it was built, we got rains, and so you're seeing the effect of the initial rainstorms that followed the building. So, and then the revegetation and recruitment of the rapidly growing plants. So you set 70 days and you're seeing this because there's been rain. If there hasn't been rain, it's going to be until the rainfall happens. Another thing I think that's worth pointing out here that I didn't show earlier is that right here is a cut, a pretty significant rill cut that's coming up, and this shrub has stopped. And basically we identified that this shrub was really stopping the erosion that was coming up the hill. The cut is progressing up the hill like this, and it's been stopped by that shrub, and the roots are holding it together and slowing the water and such. And so we just really wanted to emphasize that protection with this wattle that we put in this location. And so it's slowing and spreading and also sinking and infiltrating water uphill from the shrub, and it's taking the pressure off of that shrub for stopping the head cut, because a lot of times the head cuts will eventually make it around the shrub and it's only a temporary stop. So we're just trying to, again, starve the head cut of water and buffer the site and increase the effectiveness of the natural vegetation and processes for maintaining the integrity of the site over time.
Incredible. And I think this is what's so great about this course that you and Jeffrey Adams of Terra Sophia are putting together, is that it's not only the technique, but it's the placement of the technique. It's the observation, it's the diagnosis of the site. Why should this go here? Why is this important here? And why here and not there? You could have put this across the entire landscape, let's say towards the far side of this photo, and you would have missed the fact that here's this shrub that's actually helping with the erosion protection. So you're backing that up. You're basically moving up the watershed, so to speak, in micro and helping to protect that. And this is just an incredible addition to the work. And for anybody who's interested in this work, definitely check out low-tech erosion control at regenerativeliving.online. Brand new course in the winter of 2022. You can learn from Neil and Jeff and learn how to do this yourself.